Hi everyone, so today we are learning liquid gas separation. So our group member is Elisa, me, Kai-Chi, and Zixin.
Sorry. Okay.
So what is liquid gas separation? So first of all, gas-liquid separation is the process of dividing a mixture into gas and liquid components based on their physical differences. So for liquid gas separation, it normally involves in oil and gas processing, chemical processing, and also wastewater treatment. So for example, we have the oil refinery separation, which remove natural gas from the liquid oil, while biogas digester, uh, inside this digester, biogas form and rises from the liquid slurry. So there are two main separation methods. First is the absorption and secondly distillation. So how the process works? Firstly, for absorption is a mass transfer process in which a vapor solute in a gas mixture is absorbed by liquid, which the solute is soluble or partially soluble. For example, when carbon dioxide in the air passes through the water, the carbon dioxide will dissolve in the water, this process is the gas absorption. And so this is how the process going. Firstly, the gas at the bottom of the tower, the gas mixture enter. Then the gas usually contains solute or pollutant that we want to remove. Then from the top, we have liquid absorbent. So the liquid is chosen because it can dissolve the target gas component. Okay, next. Next, the liquid absorbent will flow downwards, meanwhile gas will flow to the top. Then inside the tower there is packed back material, which will increase the surface area for the reaction to happen. Okay, next. Okay, so inside the column, as the gas rises and the liquid flows down, the solute from the gas will dissolve into the liquid, and this is the absorption process. So at the top, there will be the clean gas, and at the bottom, we'll have the liquid which contain the gas molecules. So at the end, the clean gas will go out at the top. Meanwhile, the outlet liquid, which is rich with the absorbed solute, will go down from the bottom. And next is the distillation. Distillation is the separation process that relies on differences in boiling points of the components in a liquid mixture. For example, when you distill alcohol and water, the alcohol which boils at around 78 degrees Celsius will vaporize before the water, which is at 100 degrees Celsius. And this allows the alcohol to be collected first. So this is the distillation column. The mixture which is called a feed will enter from the middle of the column. And before that, it is heated in a furnace. So part of it become vapors, and while the rest will remain as liquid. So as the vapor move up, it will cool down, and the component with lower boiling point will stay in the vapor and move towards the top, while the heavier component will condense and flow back down. So now at the top of the column, which is vapor rich in light components, is condensed into a liquid, and this is called the distillate. Meanwhile, at the bottom, the heavier liquid will remain, and this will be the residue of the reaction.
So for the unit operation and equipment, we have Three example: distillation column, scrubber and condenser. First, distillation column, at the reflux, the portion of condensed liquid sent back to the column from the accumulator, and condenser is found at the top of the column. It cools and condenses the vapor coming from the column using cooling water. Accumulator, also known as a reflux drum, it collects the condensed liquid from the condenser. Top product, also called distillate. This is the purified lighter, which more volatile component that exits from the top of the column. Vapor from reboiler. The vapor produced in the reboiler re-enters the column, helping with the separation by enriching the vapor phase with more volatile components. Bottom product is the heavier, which less volatile component collected at the base of the column after separation. Reboiler, located at the bottom of the column, use steam to heat the liquid mixture, generating vapor that rises to the column, and this vapor carries the lighter components upward and leaves behind heavier components. And last, feed mixture. The feed is the mixture of components to be separated, introduced into the column at specific tray level depending on its composition and desired separation efficiency. Next, condenser. Turbine exhaust steam is the steam coming out from the turbine after doing work, turning the turbine blades. The exhaust steam still contains heat energy and enters the condenser to be cooled and converted back into water. To ejector vacuum system, is the ejector vacuum system remove any non-condensable gases like air that could reduce efficiency or pressure inside the condenser. Flangers these are connection points that join the condenser to other parts of the steam system, such as the turbine exhaust or vacuum system. Tube sheet is a metal plate that holds the cooling tubes in position. It ensures that water flows through the tubes while steam surrounds the outside of the tubes, keeping both fluids separate but allowing heat transfer. Condenser, the liquid water formed after the exhaust steam has condensed. This condenser is pure and can be reused as boiler feed water, reducing water and energy waste. Water inlet is cooling water enters the condenser through this inlet. It flows through the tubes inside the condenser and absorbs heat from the exhaust steam, helping the steam condense into water. Flange cover plate. This cover seals the condenser and allows access for maintenance. It connects section of the condenser using bolts and gasket to prevent leaks. And last, water outlet. After absorbing heat, the warm cooling water exits through the outlet. This water is usually discharged to a cooling tower or reused, depending on the system design. Lastly, we have scrubber. Clean gas out. The clean gas is released into the atmosphere free of contaminants. Mist eliminator, it positioned at the top of the scrubber. It removes small liquid droplets, which is mist, that are carried upward by the gas. This prevents moisture or chemical from leaving with the clean gas. Pack bag, it's filled with making material like rings, saddles, or spheres that provide a large surface area for the gas and liquid to interact. As the gas flows upward and liquid flows downward, mass transfer occurs. Contaminants in the gas dissolve or react with the liquid. Liquid reservoir, it collects the scrubbing liquid after it has absorbed or react with contaminants. The liquid here may contain dissolved gases or particles removed from the gas stream. Scrubbing liquid out. The used scrubbing liquid exits the system through this outlet. It can either be treated, regenerated, or safely disposed of depending on the process. Contaminated gas in. The dirty or polluted gas enters the scrubber. The gas usually contains dust, harmful gases, or other pollutants that need to be removed before being released into the atmosphere. And last, liquid distributor. spray nozzle, which located above the pack bag. It sprays the scrubbing liquid evenly over the packing material. It ensures full wetting of the packing for efficient absorption or chemical reaction. And for the application of distillation column, in petrochemical industry, it separates crude oil into useful products like gasoline, diesel, and kerosene. In pharmaceutical, it purifies solvent and separate chemical compounds. And food, beverage, and industry, it used in alcohol production, for example, like ethanol distillation. And the benefits to society and environment, it provides essential fuels, medicines, and purified materials. It supports recycling and purification processes and reducing waste. And it enables efficient resource utilization by separating valuable components from mixture. Next, application for condenser in power plants is condenser used in thermal power generation, like coal, gas, or nuclear, to condense steam exiting the turbine. And in refrigeration and HVAC system, it condense refrigerant in cooling cycle. And in industrial process plant, it recovers and reuses steam for heating and processing. The benefit to society and environment, it improve energy efficiency by recycling condensed steam as feed water, saving fuel and water. It reduces thermal pollution by controlling heat discharge to the environment, and it helps maintain steady electricity supply and promotes efficient use of natural resources. And lastly, application for scrubber in chemical plants and refineries. It removes acidic gases like SO2, HCl, or ammonia before releasing exhaust gas. In fertilizer and pulp industries, scrubber treats processed gases to prevent harmful emissions. And in metal processing plant, it captures dust and fume produced during smelting or coating operation. And the benefit to society and environment, scrubber reduce air pollution by removing harmful gases and particulates. It protects human health from exposure to toxic emission. And lastly, it helps industry comply with environmental regulation and reduce greenhouse gas output.
Now is for comparison of absorption and distillation. For absorption, the principle is gas is absorbed into a liquid solvent. It usually require low energy because there is no phase change of the gas. The operation happens at low temperature, which means it's more energy efficient and has lower operating cost. This method is suitable for separating dilute gas mixture and for selective separation. In contrast, distillation works by separating components through boiling point and condensation. It requires high energy because it involves heating for vaporization. It also operates at high temperature and has higher operating cost. Distillation is more suitable for high concentration mixture and volatile components. Next, uh, now we have some the latest technology that are improving absorption process. The first one is advanced solvent. These are innovative chemical solutions designed to be more efficient than traditional solvent. For example, include uh, ionic, ionic liquid, non-aqueous solvent, and deep eutectic solvent. This help to improve absorption efficiency and reduce energy use. The second is membrane absorption contactor. This use a gas permeable non-wetting membrane to separate a gas from a liquid without direct contact. This method can achieve better mass transfer and is more flexible to operate. The third one is hybrid absorption system. This combine absorption refrigeration system with other technology like ejector or compression system. Uh, this is to enhance performance and improve efficiency. Uh, Now is for technology for distillation. The first one is packed distillation column. Packing material increase the surface area for better contact between vapor and liquid. This result in lower pressure drop and improve efficiency. The second is heat integrated distillation. This method increase energy efficiency by transferring heat internally between the rectifying and stripping section of the column. It reduces the need for external heating. The third is reactive distillation. This combines a chemical reaction and separation in a single unit. It helps lower operating costs, improve energy efficiency, and reduce environmental impact. In conclusion, liquid gas separation is essential in many industries such as oil and gas, power generation, and chemical processing. Technic- Technical like absorption, distillation, and scrubbing help remove impurity, recover valuable product, and improve overall process efficiency. This method also play a big role in protecting the environment by reducing emission and waste. With the introduction of new technologies such as membrane contactor, advanced solvent, and reactive distillation, these processes are becoming more efficient and energy saving. Overall, this innovation support sustainable industry operation and contribute to cleaner product. Thank you.